Math 8, Unit 8, Lesson 2, making inferences about bivariate data. Okay, what we previously learned in Lesson 1 was some vocabulary, gaps, clusters, outliers. We even talked about what might cause those in those different situations. Types of linear correlations, your positive and your negative, and interpreting individual data points, which we did a little bit of that as well. In today's lesson, we will focus on using given data to extrapolate or interpolate. So extrapolate means to estimate and make a prediction outside of the data points range. So if you're predicting the future, all you have are data points for the past up through the present, and you have to extrapolate to get into the future because you have no data points in the future. Interpolate is when you estimate and make a prediction between data points. This is where there is a gap in the data and you use the data around it to estimate what the data point would be in the middle. We'll also be making inferences based on the bivariate data. Now in the future, things to expect, we are going to be using a linear function to model bivariate data. This is one of those y equals mx plus b. We will take the line that tends to follow the points, write an equation for it, and use that line to make predictions. And that's actually what a linear model is. We'll create a linear model to fit data. We're going to interpret the slope and intercept of a linear model. What does it mean? And we will comment on the reasonableness of a linear model. When we create a linear model, how good is it? For what numbers will it work? Where does it not work? It's kind of a limited domain of a function. When does it work? When does it not? So in the notes, I can use a scatterplot diagram to make predictions and model situations using a linear function. Okay, a lot of vocabulary here. A line of fit is a line that closely follows the data points. To interpolate is to use patterns to predict what lies between data points. If you use patterns to predict what lies beyond the data points, then you extrapolate. So there's interpolate and extrapolate. Now I've got a good picture here that gives a visual interpretation of these vocabulary terms. Extrapolate is to estimate the y-intercept right here. My data only exists down here. I don't have any data over here. So I extrapolate. I use the patterns to go extra outside of my given information. Okay. Interpolate would be to go inter between different points. So you might use interpolation to estimate a value in a gap. You don't have any data there, but you can estimate what it would be if that data point did exist. And then a line of fit is helpful for making predictions. And in the future, we'll be taking these lines and doing your y equals mx plus b. We won't do that today. Today we are just looking at using the visual representation, the line, to make the prediction. So it does require graphs. So on the first one, we've been looking, let's say you've been working on a science project for 8 months. Each month you measured the length of the baby alligator. And the data's here. We're going to graph it. Use the following steps to predict. Now, what is up with this? Oh, I've got my data with a box around it. There, it went away. Okay, we're going to graph the data in a table. So I previously graphed this so that it's more quick and you don't have to sit through the video and watch me plot points, because that is very entertaining, I know, when you're trying to sleep. So here's all the dots. I've got 8 of them from the month of 0 through the month number 7, 0 being September, 7 being April. We're going to draw a line of fit that closely resembles that. I'll just use my line drawing tool, and maybe I'll do a little bit of adjustment. Let's bring down this side of the line a little. Now, it's a good line of fit if all the points are pretty close to the line. There's about the same number above as below, and actually I probably ought to make it a little bit more like that, because now there's several points on the line. We've got a couple below the line here, a little bit above the line. We've kind of averaged it out, made it balanced. Okay, there's my line of fit. Use the line of fit you drew to extrapolate the size of an alligator next September. Okay, next September, we need to decide what the month number is going to be. If September is month number 0, the next September is exactly 12 months later. So we're looking at month number 12. Now for this would go, I'm going to extend this line a little bit. And I'm trying to estimate month number 12. It looks like it's a little bit above my graph. So 33, 34, 35, maybe 35 and a half or 36. Excuse me. I'm going to go with saying this is about 35. So we would expect to have the alligator be about 35 inches long. Now, it's not guaranteed it'll be that long. This looks like a pretty good graph, so it's probably going to be pretty close. The only thing that might change that is if the biology of the alligator causes it to grow at a different rate. Humans have that. We go through growth spurts, and as we get into adulthood, we don't tend to grow in height anymore, but we do grow other ways. Later, we will do this with greater precision by creating a linear function to model the bivariate data and substituting values. Don't get too worried about this. You just pick a couple of points, you do your slope, you do your y equals mx plus b, you plug stuff in, you solve for b, and then you can write your function. Just like we did in Unit 4 and in Unit 5. It's back in Unit 8. Okay, the table shows the depth of a river X months after the monsoon season ends. Make a scatter plot of the data to draw a line of fit. Now, for the YouTube video, I've previously plotted these points, so you don't have to watch me plot them. And you can see that it looks like it's going down over time, which makes sense. If you're unfamiliar with what monsoons are, monsoon is heavy rain, and a monsoon season is a lot of heavy rain. We don't get those here. We're not in a tropical location. B, use the line of fit to predict the depth in month 9. Interpret the reasonableness of your answer. Okay, month 9, according to my line, looks like about 3. 3 feet, right? Yeah, 3 feet deep. How reasonable is my answer? It's pretty reasonable. It looks like where it's going through. That's nice. Now, moving on to the next part. Use the line of fit to predict the depth in month 11. Interpret the reasonableness of this answer. Okay, month 11 would be right here, and it looks like it's at about -1. So -1 feet of water. Now that doesn't make sense. That sounds like, that doesn't make sense. You can't have -1 foot of water. When it's dry, you get 0 feet. There is no -feet of water in a river. So that doesn't make sense. It's not going to get below 0. So this linear model does fall apart after it goes to 0. Another thing to consider, monsoon seasons are annual. By the time you're up in month 11, probably 10 and 11, the next monsoon season has started, and this is actually going to go back up here and repeat the cycle, where it'll get really high, and then it'll level off over time. So it's cyclical. It'll go through a cycle. Okay. Hydrocarbons. Okay, this is where we're looking at, by the way, back here on this one, I forgot to click those buttons to give us the, come on, where's the line dots? I forgot to label the axes, but there they are now. Number of months after monsoon season and depth of river. Anyway, here on the hydrocarbons, draw a scatter plot comparing the number of carbon atoms to the their boiling points. I went ahead and graphed graphed all of these, so we can go through this a little more quickly. All right, there we go. It looks like as you get more carbons in the carbon chain, it gets a higher boiling point. The data show that quite well. Draw a line of fit through the data. So I'm going to have to do a little finagling here to try to get this to look good. I want to be as close to the points as possible. That actually looks pretty good. It's pretty close to a straight line here. Predict the boiling point for pentane, which is C5H12. Okay, C5, it's got 5 carbons in it. So 5, it looks like it's right here around 25-ish, 25 degrees Celsius. Now, I did look it up previously. The actual is about 36, which if I plot the point 36 here, you'll see it's pretty close to that line. It's reasonable. And our estimation of 25 degrees Celsius is reasonable. It is close. It's not exact. If we were a little bit more precise in our line drawing, maybe the line should have been a little further over here. But can't beat yourself up over it. It's just analyzing data. This is kind of how statistics work. Okay, the boiling point of heptane is 98.4 degrees Celsius. Use the equation of the line of fit. We're actually not making the equation. We're just going to use the graph to predict the number of carbon atoms in heptane. Okay, 98.4, that's about 100, and it is slightly more than 7. Okay. Now you can't have slightly more than 7, so heptane is going to have 7 carbons, 7 carbon atoms. By the way, hept, if you know any of your Greek naming nomenclature, hept does mean 7, and the actual number of carbons in heptane is 7. All right, in the future we will be doing modeling with y equals mx plus b. We've got a couple of activities we're going to do leading up to that. On this assignment, number 1 looks like you get to graph the data here. You get to write the ordered pairs, graph them, describe the relationship. Is there a drawing a line? It doesn't. I don't see that. Number 2, it's already given you a graph, and it's having you estimate. So you'll want to do a line there, and then you estimate for 70, which there are no dots for 70, but you can estimate it based on where it should be if there were. How much did the server earn for 5 hours of work? That one, there's actually a dot there you can use. Describe the relationship shown by the data, positive, negative, what kind of relationship. Number 3, determine the y-intercept. Number 4, solve for r, that's back at unit 1. Number 5, solve for x. Remember, the angles in a triangle add up to a specific number. Number 6, this is review back to understanding proportional relationships. It's going to go through which of these 4 points. M is the slope. So that's what these mean. And, well, that doesn't have an M in it. Number 7, another one with a scatter plot. You're making some comparisons. Number 8, another scatter plot, and there's a few questions about it. Thank you for watching.